everybody. Thanks so much for joining this talk. My name is Brad Munday. I'm the head of our machine learning engineering here at Modzy. And today I'm really excited to walk you through what we call robust and resilient edge cloud inference solutions for large language models, or LLMs. I'm really excited to be a part of this event. I think the revolution of large language models and generative AI, it's taken our world by storm in the last 9 months, and there are a lot of really exciting, great talks that I can't wait to tune into. For this talk today, I'm going to be maybe taking a slightly different angle on LLMs, and that's because I'm going to be talking exclusively about running LLMs at the edge. Now, sometimes that can sound daunting, and folks the initial reaction may be, why is that? And why would I want to do that? What are the applications? Well, I'm going to cover all of that, starting with some real world applications of running LLMs at the edge. Talking about how we define edge, and then ultimately getting into some of the architectural and strategy decisions that we make from our experiences here at Modzy when constructing these architectures and deploying these out to the edge. So let's dive right in. As I mentioned, oftentimes the immediate reaction is, why would LLMs need to run out in the real world? They're very resource intensive. They're massive, massive models. How do we even do that? Well, there are a handful of real-world applications in use today of these LLMs running. I think a great example of that is the Qualcomm partnership with Meta. And what they're doing is working on a Llama-enabled AI system and capabilities into some of their flagship devices, like cell phones and PCs and machines, set to be released in 2024. So I think that also highlights where we are with deploying LLMs at the edge. We're still early on. And so here at Modzy, we think of this kind of the same way we think of all AI ML. Obviously there are some resources and some differences that I'll talk about in a few slides. But largely speaking, for us, our mission is to help organizations deploy AI and ML to any model or to any device anywhere. And we think of LLMs the same way, as I mentioned. A couple other examples, I think that are really ripe for running LLMs at the edge include autonomous vehicles, include smart home systems, speakers, security systems, and even, medical devices to help healthcare professionals provide a best experience for their patients. In addition to edge workstations and gaming systems, and really that list goes on and on, just to name a few. But the point is, this is already happening today, and I'm excited to show you how we approach the problem, and also a cool demo that illustrates this a code llama model actually running at the edge. But before we dive in, I'll start by defining the edge, because to us, the edge is so much more than just single board computers, and that's often a misconception that I'm going to try to debunk today. It's not just your Raspberry Pis, your tablets, or your cell phones or wearables. It's a lot more than that. More specifically, we like to define this cloud to edge spectrum, also referred to sometimes as the spectrum from the near edge to the far edge. And as we go kind of from left to right, and as I go down these different classes of edge devices, what you'll notice is sequentially they're products of more and more or decreasing power availability and network connectivity. So the difference between cloud edge type of infrastructure and the far edge vary significantly. The far edge has little to no network connectivity and very little power consumption, whereas the cloud is exactly the opposite. So just running through these quickly, we'll start with cloud edge. That is the set of infrastructure that offers computing capabilities analogous to that of cloud services. A great example of this is multi-edge computing systems, where these massive server racks sit at the base of 5G cell towers that telco providers use, for their customers and their business customers. Moving on down the line, compute edge is what we refer to as more localized micro data centers. Now, these are the devices that have a lot of compute, 32, 64 CPU cores, hundreds, if not terabytes, gigabytes of RAM and disk storage, and the ability to be compatible with different GPUs. Now, these have a ton of compute, but they're more, box-like edge server infrastructure. Things like the HPE EL series, the EL 8000 is a great example. Dell has a Power Edge server. Intel's NUC Extreme 13 is very large, and there's a ton of compute, again, with GPU available and lots of memory available. And this type of device can be portable, across your manufacturing floor, retail systems, different labs, but has the compute and some of the resources needed to run LLMs. Next, we'll get into the device edge category. This is where your single board computers really live. Raspberry Pis, Intel Upboards, some of the NVIDIA Jetson modules. And then as we kind of round this out with sensor edge and far edge, that's where we get really into the IoT sensors and devices that collect data directly. Cameras, sensors, microphones, things that exist in our daily lives pretty much everywhere, but in most cases are connected to the cloud, in some capacity. And finally, far edge is what we like to think of as microprocessors, microcontrollers that are embedded within robotics and, are very little power, no operating system, and no real connection to the outside world. So it's important to define edge as really meaning a lot of different things when you think about deploying large language models to the edge. Which leads me to maybe the crux of this entire talk, and that is why we want to run LLMs at the edge. And the reasons, there's a lot of overlap between these reasons and the reasons that you want to move any AI machine learning system out to the edge. The idea of taking the AI model and having it, process the data right where the data is captured instead of transferring data back and forth between cloud and data center and edge nodes. So, the first factor that we see and talk with our customers and see industry-wide is bandwidth and network access. Network infrastructure is not always available. That may mean there's a remote environment excluded, or cut off from the internet and outside networks, or it may mean that the networks just go down due to natural disasters or power outages. Running your models on the edge can reduce some of these risks of network outages and issues. The next factor is this idea of real-time latency. It's no mystery that there is a non-trivial cost to transferring data between your edge device and the cloud. And if we can further, make LLMs integrated into real-time applications, it can provide a ton of value. Maybe the hottest topic right now as it pertains to LLMs and things like ChatGPT and Bard are privacy and security concerns. For good reason, these enterprises are looking to alternatives to using cloud-hosted large language models because of the concern of an internal data leakage, whether that's employee PII or business conversations or internal business data, trade secrets, et cetera. That could have a detrimental effect and impact on a business. And finally, maybe the biggest factor driving LLMs and AI ML out to the edge is cost. There can be a significant reduction in cost from moving your cloud-hosted solutions out to the edge. In fact, kind of a fun and statistic that speaks to the scale we're talking here, we found is that it's estimated that by 2028, if 20% of all the generative AI workloads are offloaded from data centers out to edge devices, we'll be reducing operating costs of running these generative AI capabilities by 15 billion. So it's a really massive scale in the next 4 to 5 years. Even more reason to consider moving LLMs out to the edge. Now, as we get closer and closer to the demo and sort of the architecture we've built and the framework we've built for doing this type of transformation of LLMs, I'd be remiss to not talk about some of the really important considerations you must make when, number one, deploying your LLMs anywhere, but especially at the edge. I won't focus really a lot about some of these techniques today, but there's lots of ways to optimize your AI models, and it's especially important for LLMs that are very resource intensive based on your use case, to minify the model with quantization or pruning, to accelerate that model inference using tools like TensorRT or OpenVINO or Onyx Runtime. All of that is really important. Just important to kind of consider these as you think about deploying your LLM and running it in a production system at the edge. And then you have to think about a whole collection of considerations and factors that make running these models on edge devices fairly complex. Layers of complexity from top down. We'll start with the device itself. And I think the biggest thing here is there a GPU on board, right? LLMs are greatly accelerated in terms of inference when a GPU is available. In fact, would highly recommend using some sort of accelerated hardware to run them. And so configuring that, setting that up is not always a trivial task. And then I think biggest thing for LLMs is resource constraints. How much RAM is available, how much VRAM is available on your GPU, what sort of CPU count do I have, and importantly, will I be running any other software on this device or a collection of devices that I need to allocate those resources accordingly and map them out. And then I just talked about how moving your LLMs from the cloud to the edge comes with a plethora of security benefits. It's equally as important to secure the device or devices at the edge that you're running these models. So, with all of these factors, considerations in mind, it becomes time to choose a paradigm that supports your use case, the best, with a combination of how you want to optimize your model, what type of configuration and setup on the device itself is necessary, and then ultimately how you're going to distribute the workloads between cloud and edge. So when I talk about workloads, I really mean two things. One is the training of these LLMs and really any AI model. And the second is the inference of these LLMs. And when we're talking about edge, that can mean a couple things, but for this context, we'll use two subclasses. One is on the device itself, and two is a network of distributed edge nodes that could share in some of the processing of these workloads. And we found all this information from an Edge Intelligence blog and publication that I think categorizes and classifies all this really well. I'll just share a couple examples that we've thought of as it pertains to these different levels of shared workloads between edge and cloud. The first is level 4, and I'll share an example that I think makes sense. Think about a voice assistant in a vehicle, and that model is likely trained in the cloud first. It's some base model that's then deployed out to a fleet of, let's say, 100 vehicles. Well, that LLM interacts with its passengers and helps with a variety of tasks. Now, it's inevitable that there will be edge cases and that the model will not be perfect and could use some improvements and fine tuning and maintenance over time, across the board. So there may be some on-device or on-device tuning specific to each passenger, each vehicle, but there are certainly some data that could be offloaded from that device back to the cloud to retrain and maintain that model, distribute the best version out to all of those vehicles in the fleet. Another example that I'll share, maybe it's a little bit different, is level 3, where the model is trained in the cloud, but inference is exclusively performed locally, and none of that data is offloaded back to the cloud. Let's think about an example I mentioned earlier, an at-home security and smart system, where in your home, there is so much private and sensitive data captured on a daily basis that you'd never want that data to go back to the cloud. And so any sort of fine tuning and training would maybe be done on the device. And again, no data would be offloaded from that device itself. And then finally, I'll actually go through an example of level 2 in the demo, where the model is trained in the cloud, but inference can be carried out at the network edge, meaning a collection or distribution of edge nodes within a single network. It could be a single edge device or a collection of them. So that said, let's dive right into this demo where we built a prototype that runs a large language model at the edge. And specifically, we built this prototype and leveraged 3 different technologies. I mentioned early on Meta's latest Code Llama model. So that's the large language model. We're using Chassis, which is our open source Python library for building containers automatically. And then finally, we're going to use Modzy's Edge tool and Edge system to orchestrate the remote deployment and serving of this model on an edge device. Now, to provide some context of the use case that we built out, it's a use case that would be applicable to oil and gas companies. More specifically, there are these geologists who are very involved and play a key role in the maintenance, monitoring, and development of oil fields. And their job, what they'll do is go out to these oil fields and take samples of oil wells and collect all sorts of data with different parameters like volume and ratio of oil and gas and water from a liquid sample on top to different readings from sensors deployed on pumps that go underground to these reservoirs. And what they do is they use this data to build 3D models of the oil field, and most importantly, to monitor the performance of each oil well over time. How much oil has already been produced, how much is left to be produced, and ultimately, how does that impact the profitability on a per oil well basis? So there's some significant impacts there, and they play a really key role. Well, oftentimes these oil fields are within confined, completely remote, network restricted environments, whether that's very remote onshore or offshore. And so what we've done is use Code Llama to build a dashboard that gives these folks, these geologists, these data analysts on site, the ability to interact with and analyze the data in real time. So from an architecture standpoint, what we did was, think about an oil and gas company's headquarters in some big city and they've stood up their cloud MLOps platform there. Included in this, again, on their own private data center, are their whole library of models, large language models, computer vision, time series. And what we want to do is in this case, we'll use Modzy's Edge feature to deploy that out to a remote device and help this business analyst interact with the model to create a dashboard. So first, I'll walk you through the workflow of how we took this model from Hugging Face. We're using a 7 billion parameter version in the Hugging Face transformers format. Convenient because there's Python code that you can copy paste and run this model. And what we did was we used Chassis, as I mentioned, to containerize this. The main idea, and I'll show you an example of stable diffusion, is that I can, in Python, load my model into memory, define a single predict function. You can think of that as an inference function. And, Chassis will do the rest. You'll pass that through, create a Chassis model object, add some requirements, some metadata, and ultimately use your local Docker daemon to build a production container in just a couple minutes. Now with that container, we can deploy it into our central model library. And what's great about this is, you can use your LLMs alongside all of your other machine learning if applicable. We'll click on this Code Llama model. We took some of this information directly from Hugging Face. And we see that this model supports all of the most popular programming languages. So today we're going to be focused on Python. From here, you can use Modzy's Edge product, what we call device groups, to deploy this out to a remote oil field facility. We've got our model right here, and we can see, as we go into this device, some of the metadata returned. There's 16 cores available, a little over 3 gigs of RAM, and a Python API that makes it really easy, standard, consistent to access any model. I'll also just show you the blank dashboard slate that we're going to populate using the help of Code Llama. So with that, I will open up my VS Code environment here. What's great about this is everything is running locally, and I've got 3 terminals up. In my first terminal, I have this Code Llama container running with Modzy's core product. I have an empty terminal here that will do most of the navigation. And then we have this Streamlit application running. Again, it's an empty dashboard right now. So I will then shrink this guy a bit. We have our Python script that we use to containerize the model with Chassis. Again, the same code I just showed you a second ago. We have this Modzy Edge inference script. This will be the main driver of interacting with our model. What this does is it uses the Modzy SDK, establishes connection to the model with our Edge client. In this case, we're just hitting it via the local host. And what we're going to do is take this dashboard Python file as the input, run it through our model, coach it along, and kind of work with it interactively. You'll see it in a second. Take the results and update that same Python file. So as I start this demo, we will pretty much stay on this page directly and jump back and forth to the dashboard to see how it's being updated. So I will kick off Inference. And the first prompt I'm giving the model, again, this model is really good at code completion. So I'm going to interact with it by the way of code comments. And the expectation is that with a code comment, this can act as a prompt. And I expect the model to do some things for me. So the first prompt I'm giving the model is to import Streamlit and Pandas libraries and create a Streamlit application configured with wide layout and give it a title, oil well analysis. After a few seconds, we see some results here. So I have some Python knowledge, right? As does the data analyst in the oil rig. And so I can, do some formatting and work with the model collectively. So that's a good start. I've got my Streamlit app and my page set. That all looks good. If I go back to my dashboard right here, we have something here. So that's a great start, but we've got a long way to go. Next, I will provide a comment that prompts the model to add a widget in the sidebar of my dashboard to upload a CSV file. So we'll run this again and see what the model comes back with. As this is running, let me open up the CSV file to just show you the CSV we're working with. Again, this captures lots of data from an oil well over the course of 2 or 3 years. While this is running, I'll also note that I mentioned this earlier, there is a T4 GPU on board, making inference accelerated and kind of tolerable to deal with from a latency standpoint. All right. So we see that we did, in fact, add a widget to my sidebar to upload this file. That's great. So I can upload a CSV file. And it looks like the model even gave me some messaging, whether the upload was successful or if there's no file uploaded. So that's a great kind of level of validation for the user. Now, they did a bunch of other, great stuff here, data selection and filtering on the sidebar, but I've got a very specific kind of vision in mind for this dashboard. So I'm going to delete that and instead prompt it with another comment. In this comment, I will ask the model to add 2 columns to my dashboard. If I go back to my dashboard again and refresh, we should see that the sidebar is there. That's great. I can upload a CSV file, which I'll do in a second. But in the meantime, I've got a clear vision for the layout of this dashboard. So we've created the 2 columns. That's great. And it looks like the model took the liberty of adding in some more logic, right? It looks like it wants to display the data on one column and looks like it repeats itself a few times. So that's actually exactly what I was trying to do. But instead, I will replace this with a different prompt. So as you can see, what I'm doing is I'm taking bits and pieces of what the model returns, customizing it to my use case, and then kind of adding additional very detailed prompts that I know the model will be able to respond to. That kind of comes through different prompt engineering efforts that we went through ahead of time, but something that any analyst or user would certainly be able to play with. So what I want to now do is have the model display my data frame and create some summary statistics for me. That will give me a good understanding of the data. It allows me to view it in a different view form, and that's great. And it actually then decided to generate some code that in the second column will visualize my data. That's exactly what I'm looking for, but I do, again, have very specific kind of requirements. So I'll delete this for now and add one final prompt. Now, this final prompt, I'm asking it to create 3 line charts for me. Basically, plotting the volume of water, gas, and oil over time. And so very quickly it does that. It looks like it did so successfully. But to verify that it did, we can go back to my dashboard. Again, I can refresh. And it looks like there's some error handling that we can handle that later. That's okay. I will upload a file here. Let's see. I'll upload my CSV, and just like that, the entire dashboard populates. I can view my data if I need to do any validation. I can see some summary statistics. It's interesting to look at the working hours of this oil well, on average about 22 hours a day. And most importantly, I have the exact visualizations I'm looking for. As a geologist, this is great. I can upload this data in real time on a daily basis and get this data analysis at my fingertips. What I'm looking for are some of these spikes in water volume, because what that means is the reservoir is running out and the samples contain more water than they should, ultimately leading to some big hits in profitability of this oil well. So again, I built this entire thing running locally with a code llama model, and with no tools like Google and Stack Overflow and some of the other tools that I might use to help me build this dashboard. I was able to build a dashboard with the help of this code llama LLM in just a couple of minutes. In conclusion, again, just wanted to say thanks so much for joining this call. As I mentioned early on, I think we are still very early on in the journey of deploying LLMs out to the edge. And it's exciting for us to deal with this on a daily basis as the market and the world continues to evolve. And we're really excited to see how powerful these applications become, some of the impacts, and some of the new innovation to come. Thanks so much for joining, and would love to be in touch with you after this if you have any questions.